Bismillahirrahmanirrahim. Assalamu alaikum dear students. Hope you all will be doing well. Welcome to Forward Public School e-learning class 10. This is subject chemistry. Chapter number 9 chemical equilibrium. Today we will discuss the third topic, that is law of mass action and derivation of the expression for chemical equilibrium constant. And I'm your teacher Mehreen Zafar. Let's start our topic. First we will discuss the introduction. Two Norwegian chemists in 1864, that is Pt3 and Gilbert, presented the law of mass action. So these two are the scientists who first introduced the law of mass action. Now we will discuss the statement of the law. How is the statement of the law? The rate of a chemical reaction is proportional to the active masses of reactant substances, or we can simply say reactants. Now the question is, what does the word active mass means? So by active mass we means the molar concentration, or we can say that the number of moles per liter expressed by enclosing the formula in a square bracket. Thus, it is clear that the rate of a chemical reaction is proportional to the molar concentration of reactant substances. Now, what is chemical equilibrium constant? Chemical equilibrium constant is actually a mathematical relation between the concentration of reactants and products. So how can we define it? It is actually the ratio of mathematical product of concentration of reactant products to the mathematical product of concentration of reactants at equilibrium. Each concentration in a chemical equation is raised to the power, which is equal to the coefficient of that substance present in a chemical equation. Now we will discuss the equilibrium constant. In equilibrium constant, the concentration of the reactant species are represented by equilibrium constant expression, which is generally represented by Kc. And if we can see that Kc value has equals to the concentration of the product to the concentration of reactants, and these concentrations are enclosed in square bracket, while A, B, C and D, this shows the chemical species, and in the superscript we have C, D, A and B. These are actually the coefficients in a chemical balance equation. Now, how is the formula of equilibrium constant? Equilibrium constant is equal to the product of concentration of products raised to the power of coefficients divided over product of the concentration of reactants raised to the power of coefficient. You can clearly understand the formula in numericals. This equation for Kc is sometimes referred to as chemical equilibrium expression. We can also call it chemical equilibrium expression. Now we will do the derivation of the expression for equilibrium constant. Consider a general reaction, that is A plus B reacts together and they give you the product C and D. So according to a law of mass action, the molar concentration of A can be written as square bracket A power A. Concentration of B can be written as square bracket B power B. Concentration of C can be written as square bracket C power C. Similarly, the concentration of D can be written as square bracket D power of D. Here the small alphabets A, B, C, D are molar concentration of A, B, C and D. Now according to the law of mass action, rate of forward reaction is directly proportional to the product of concentration of both reactant A and B, which can be written as R is directly proportional to the concentration of A and B. Now, removing the sign of proportionality into equality, we will have to keep a constant, and this constant is called rate constant for the forward reaction. Similarly, the rate of reverse reaction is again directly proportional to the concentration of the C and D. Removing the sign of proportionality, we will bring a constant, that is Kr, and this Kr is called as the rate constant for the reverse reaction. Now dear students, at equilibrium state we have the rate of forward reaction equals to a rate of reverse reaction. Therefore we can write as Rf equals to Rr. Now putting the values in the above equation number 3, we can get Kf concentration of A and B equals to Kr concentration of C and D. Dear students, after rearrangement, we get the shape of the equation as ratio of the Kf or Kr equals to concentration of C and D divided over concentration of A and B. As the ratio of Kf or Kr equals to Kc, so the above equation can be written as Kc equals to concentration of C and D divided over concentration of A and B. For any chemical reaction, when we have a large value of Kc, it indicates that the product concentration are greater than those of the reactants and vice versa. Now we will discuss some factors that the equilibrium constant is independent of pressure, concentration and catalyst. As well, the value is constant for any particular reaction. Dear students, thank you for your attention. This is the end of topic number 3. We will be back with another interesting topic. Hope you have understood it. Stay home, stay safe, stay live.